This is the fourth video. In this video, we are going to learn the gauge length and percentage elongation. The topics covered here are gauge length, percentage elongation, neck forming of steel, and cup cone fracture of steel. Now, when the material or the steel is loaded beyond ultimate stress, here the cross-sectional area of the specimen goes on decreasing uniformly, forming a neck. Before neck forming, the entire material evenly undergoes plastic deformation. So here we can see the tensile load is applied, and this is the diameter of the bar. What happens is, before the ultimate load, the diameter of the bar decreases for the full length, and there is increase in length of the bar. But after the material reaches its ultimate stress, then the neck forming starts at some point. So this is the way how the bar diameter decreases here, and further when then it decreases something like this, the shape becomes, and again then it becomes something like this. So this is called as neck forming. From here the diameter decreases, then it decreases here for still further, and it decreases still further. If when the experiment is performed in the lab, and when we reach the ultimate load, and after that ultimate load, when it starts decreasing the load, if we observe the bar carefully, we can see this neck forming, and this shape comes to the bar. This is known as neck forming. Once unstable neck forms, the cross-sectional area of the neck will continue to decrease under the load till the failure, when the unnecked material no longer plastically deforms. This is how the neck forming of the steel takes place in the region from the ultimate stress to the breaking stress. Now, when the material breaks, when the steel bar breaks, at that time we can see the bar something like this. The after necking, when the bar breaks into two pieces, cup shape is formed of one piece, and cone shape is formed of another piece for ductile materials like steel. This is known as cup cone fracture. This is the tensile failure of ductile material. So when the steel breaks into two pieces, for one piece such cone shape is formed, and for the another piece such a cup shape is formed. And this can be very well observed in the practical, how the cup cone fracture takes place in the when the failure of steel takes place. And steel is a ductile material, and ductile material means we can draw wires from it, and it gives us a very good yield point and percentage elongation. More of ductile material we will learn in the next video. Here what you remember is how the fracture cup cone looks like, and we can observe this failure in the practical when you actually perform the test. So this is a tensile failure for ductile materials. So in the field, when some failure takes place, you can study the failure pattern, and you can make out that, oh, this is a tensile failure. Now, what is a gauge length? In the experiment of tension test on mild steel, what we do is we take a bar and we punch the bar at gauge length. Now, what is a term gauge length? The term gauge length refers to the part of a test specimen actually being measured for elongation during a tensile test. The term refers to original length of a specimen before the test starts. The gauge length tends to be standardized based on the size and type of specimen being used. The permanent elongation at fracture is measured by means of test piece of circular section in which the gauge length 1 is equal to 5 times the diameter. Here what we do is, suppose the bar is of 10 mm diameter, then its gauge length L1 will be 5 times the diameter, that is 5 into 10 is 50 mm. So if this bar is of 10 mm diameter, that at 50 mm such markings are done. So this length L1 is 50 mm. So for the full length of the bar at 50 mm we do a marking, we do a punch here, and then the bar is kept in the UTM, fixed in the UTM for the tensile strength. And what happens is, when the cup cone fracture takes place, suppose that the bar breaks say in this region, then from this point we join the two pieces, we keep the two pieces again together after the piece breaks, and from this point to this point we measure the length. That is, what is the length after it has broken. This is L1 is 50 mm, and after it breaks, before breaking the bar elongates. So when after breaking we join the two pieces together and we measure this length, it will not be L1 but it will be more than L1. If the bar breaks here, if the bar breaks here in this gauge length, then from this point to this point we measure the length, final length after failure, which we call as L2. So that is why we mark the gauge length on the bar, and the gauge length for a circular bar is taken as 5 times the diameter. If the diameter is 10 mm, then is 5 times means 5 into 10 is 50 mm, and this gauge length marking is done throughout the length of the bar before we place the bar in the UTM for the testing. Now suppose this is the L1 gauge length, initial length, and after elongation L2 is the final length. Then the elongation will be final length minus original length. So L2 minus L1 is delta L, that is the elongation or change in length, and percentage elongation will be elongation divided by the original length into 100. So percentage elongation is equal to delta L upon L1 into 100, but delta L is L2 minus L1. So percentage elongation, to calculate the percentage elongation, what we do is the final length minus the original length, or it is gauge length L1 divided by the L1 original length into 100. This is how we calculate the percentage elongation of the bar. Be a master. Thank you.